Infant and Toddler Cognitive and Brain Development, Veronica Vasquez ECD 310, Applied Early Child Development, April 12, 2026. ELOF domain is cognition. Age group is infants and toddlers. This presentation examines cognitive development in infants and toddlers. The content is informed by TED Talks from Alison Gupnick and Laura Schultz, and the Angier article, The Early Learning Outcomes Framework, and Module 4 course materials. The primary focus is the cognition domain within the Early Learning Outcomes Framework, which addresses how children explore, remember, and solve problems. Introduction: Brain and Cognition. Cognitive processes are shaped by brain development. The synaptic connections are established because of experimental input. The cognition domain within the Early Learning Outcomes Framework addresses these developmental processes. Cognitive development depends on brain growth. These processes are biologically linked. In this image above, you can see, this one right here, you can see the synapse formation. Early experiences build and reinforce these neural connections. The brain also undergoes pruning, which preserves frequently used connections. According to the National Center on Early Childhood Development, experiences shape brain architecture. This is reflected in the ELOF cognition domain, illustrated how thinking manifests in behavior. Exploration builds the brain. Confirmed knowledge number 1, exploration and cause and effect learning. Engagement in exploration enhances the development of neural pathways. Repetitive activities facilitate the formation of neural connections. An early learning outcomes framework, exploration and discovery. Exploration serves a critical developmental function by facilitating brain growth. In the depicted scenario, the infant repeatedly drops objects, and this repetition contributes to the strengthening of neural pathways. Alison Gupnick suggests that infants behave similarly to scientists by systematically testing cause and effect relationships. Repeated experiences enhance synaptic connections, thereby supporting the learning process. For instance, when an infant drops a spoon, the experience facilitates understanding of gravity, auditory feedback, and cause and effect relationships. These behaviors are consistent with the ELOF exploration and discovery indicator, which states that infants actively explore objects and events and repeat actions to understand outcomes. Memory development. Confirmed knowledge number 2, memory and recognition. Memory is defined as the strengthening of neural connections. Repetition facilitates the development of recognition. Early learning outcomes framework. Memory. Memory is a result of repeated neural activation within the brain. The image illustrates infants' ability to recognize caregivers and anticipate daily routines, which would be these two pictures. And Laura Schultz states that infants retain patterns and utilize them to predict future outcomes. Repeated experiences strengthen neural pathways. For example, when a child anticipates feeding time, the behavior demonstrates memory development. This observation is consistent with the ELOF memory indicators. This is consistent with memory indicator, which states that infants recognize familiar people, routines, and events, and demonstrate anticipation. Problem solving. New insight number 1, early problem solving abilities. Trial and error learning processes. Neural plasticity facilitates effective problem solving. And then the ELOF is reasoning and problem solving. Problem solving demonstrates neural plasticity, indicating that the brain possesses a capacity to adapt and recognize in response to new experiences. The infant depicted employs multiple strategies to obtain a toy, which would be this one, as well as this one and this one. Natalie Angier reports that infants exhibit early reasoning abilities. Each attempt reinforces neural pathways associated with problem-solving processes. For example, when infants move obstacles to access a toy, this behavior demonstrates cognitive flexibility. This observation is consistent with the reasoning and problem-solving domain of the early learning outcomes framework. This further supports by the ELOF reasoning and problem solving indicator, which states that infants use trial and error to achieve goals and solve simple problems. Logical thinking. New insight number 2, infants use logical reasoning. Infants use evidence-based reasoning, detect unexpected outcomes. This was the moment my perspective shifted. Previously, I believed infant behavior was random. However, I now recognize that it follows logical patterns. In this image, infants gaze longer at unexpected events, which indicates early reasoning abilities, which would be here. And then Schultz explains that infants form conclusions based on available evidence. This observation demonstrates early logical thinking, which is supported by ongoing brain development. This finding aligns with the reasoning indicators outlined in the early learning outcomes framework. This is consistent with the ELOF reasoning indicator, which states that infants make predictions and adjust their expectations based on observed outcomes. Environment shapes the brain. New insight number 3, environment and relationships shape cognition. Brain development is influenced by external factors. Interpersonal relationships facilitate the formation of neural connections. Both biological and environmental factors, including epigenetic mechanisms, contribute to development. According to the Early Learning Outcomes Framework, learning occurs through interactive processes. Brain development is not an autonomic process. Instead, it is shaped by the experiences and environment in which a child is exposed. As illustrated in the accompanying image, serve and return, interactions where a caregiver responds to an infant's cues are critical for establishing robust neural connections. According to the National Center on Early Childhood Development, these responsive interactions fundamentally shape brain architecture. The Module 4 Brain Development section explains that consistent and responsive caregiving straightens neural pathways associated with language, memory, and reasoning. This concept is related to epigenetics, where environmental experiences influence gene expression. In contrast, limited interaction or neglect can weaken neural connections and negatively impact development. This observation aligns with the ELOF connection domain, particularly indicators that infants learn through social interactions, engage with caregivers, and use relationships to support exploration and learning. This information deepened my understanding as I now recognize that relationships are not solely emotional, but are also essential for cognitive and brain development. Play is essential for brain development. New insight number 4, play is a primary way children learn. Engagement in play fosters the development of neural connections. Play supports the development of problem-solving abilities and creativity. Participation in play encourages the development of skills related to science, technology, engineering, mathematics, STEAM. According to the Early Learning Outcomes Framework, play promotes exploration, problem solving, and imitation. Play is not merely a form of entertainment, it is a fundamental to brain development and learning. As illustrated in the accompanying image, children engaged in open-ended play actively explore, solve problems, and construct meaning. Introducing academics instruction prematurely may restrict development, whereas play fosters more profound learning. The Module 4, Supporting Development and Learning Resources, explains the play enables children to test ideas, explore materials, and develop critical thinking skills. Play further supports early STEAM learning by providing opportunities for children to experiment, construct, and solve problems through hands-on experiences. For example, when a child builds with blocks, they learn about balance, spatial awareness, and cause and effect, while simultaneously straightening neural pathways. From a brain development perspective, play reinforces neural connections associated with creativity, reasoning, and executive functioning. This observation aligns with the ELOF condition domain, particularly with indicators such as exploration and discovery. Children actively explore and manipulate objects. Reasoning and problem solving, children use trial and error during play. Imitation and symbolic play, children engage in pretend play and in real life experiences. My perspective shifted upon realizing that play is not distant from learning, rather it is the primary means by which infants and toddlers acquire knowledge. As an educator, I now recognize the importance of prioritizing play-based learning environments over overly structured instruction. Synthesis, infant learning as a brain and experience. Learning results from the interactions between brain development and experiential factors. Infants demonstrate active engagement and significant learning capabilities. Learning in infancy can be characterized by several key attributes: exploration, social, logical, and play-based. Infant and toddler cognitive development is a dynamic process influenced by both neurological maturation and experiential factors. Learning in early childhood occurs through exploration, social relationships, problem solving, and play. Alison Gutnick suggests that infants function similarly to scientists by actively exploring and testing ideas. Laura Schultz demonstrates that infants employ logical reasoning to interpret their environment. Natalie Angier highlights that infants engage in fundamental problem-solving and reasoning processes. Module 4 content further explains that early STEAM learning is imitation through hands-on exploration and direct interactions with the environment. From a developmental perspective, these experiences strengthen neural connections, particularly during the first 3 years when the brain exhibits heightened plasticity. The ELOP cognition domain categorizes these abilities into observable indicators, including exploration and discovery, actively investigating objects and events, memory recognizing patterns and routines, reasoning and problem solving employs trial and error. Imitation and symbolic play learning through social interaction, pretend play. This synthesis demonstrates that infants are not passive learners, rather they are active and capable thinkers whose development is shaped by meaningful interactions and experiences. This deepened my understanding as I now recognize how brain development, environmental factors, and social interactions collectively support cognitive growth. Application to practice. Foster environments that simulate cognitive development. Promote the development of responsive relationships. Encourage play and exploration to facilitate learning. Utilize the early learning outcomes framework to inform educational practices. Based on what I have recently learned, I plan to design my classroom in ways that support both brain development and cognitive growth. I believe classrooms should have open-ended, hands-on materials that help children explore and solve problems. Module 4, Supporting Development and Learning, emphasizes that children learn more effectively through active engagement and meaningful interactions. For example, I plan to incorporate sensory bins, block areas, and STEAM-based play to enable children to test ideas and explore cause and effect relationships. I will also prioritize responsive caregiving by talking, listening, engaging, and serve and return interactions to strengthen neural connections. According to 0 to 3, responsive interactions are key for building strong brain architecture. I will use the ELOP cognition domain to guide my observations and planning, especially by providing materials for hands-on learning and exploration. ELOP memory, I will create consistent routines and experiences. For reasoning and problem solving, I will encourage children to learn through trial and error. I will support imitation and symbolic play by encouraging pretend play and social interactions as suggested by the ELOP framework. For example, if I see a child stacking blocks over and over, I will recognize this as problem solving and help by asking open-ended questions. This approach reflects my deeper understanding that learning is driven by brain development, relationships, and meaningful experiences rather than solely by direct instruction. Moving forward, I will be more intentional in observing and supporting cognitive development through daily interactions and play. References. Here's a list of all my references I used, as well as my AI statement. I use AI tools to assist with grammar, punctuation, and checking APA formatting. All ideas, examples, and reflections represent in this assignment are my own and based on my understanding of the course materials. Thank you. I hope you enjoyed my video.